So we're going to continue on with chapter 41, which was climate change. We talked on Wednesday about the basically global warming, climate change, and the greenhouse effect. And you wrote up this experiment for me. So today we're going to have a look at carbon dioxide concentration and I suppose what's causing it and why is it a bad thing. There's probably a little bit too much detail here, so we'll talk through it. Okay, so carbon dioxide is released by many means. Some of these we've talked about, so the burning of fossil fuels, the production of cement involves a process of producing lime, which is not good and releases a huge amount of carbon dioxide. So that's why people who are building sustainably, if you ever watch Grand Designs or any of those things, there's always people trying to build sustainably, and they always try to build with as little cement as possible to reduce their carbon footprint. So there are different products out there, but obviously they're colossally expensive compared to cement. But yeah, if you use a large amount of cement, there is quite a big effect on the environment. Extraction or removal of products, processing, transport, and distribution. So basically, the entire production and manufacturing of fossil fuels produces a huge amount of carbon dioxide, as well as then when you get those fossil fuels and you burn them, more carbon dioxide. Disposal, so like dumps and stuff, trying to dispose of waste products and have them dissolve. Addition of fertilizer into the soil, and then the agricultural industry, and so farming on a commercial scale would release quite a lot of carbon dioxide. Natural activity, so I suppose linked in with the agriculture thing, animal and plant respiration. So obviously us and the animals, we breathe in, we exhale carbon dioxide. Volcanic eruptions produces carbon dioxide, and a carbon dioxide exchange between oceans, and the atmosphere. Okay, so there's a balance. There's meant to be some carbon dioxide in the atmosphere. It's meant to be there, and there is a balance, which up until the 1700s with the Industrial Revolution, the earth was maintaining quite well. So obviously they had all these people on the earth, animals, we were breathing out our carbon dioxide, but we also had our trees and our oceans, which were absorbing that carbon dioxide, and the trees were releasing oxygen back into the air, which we then breathe in. So the balance was working. So it's not that there's not meant to be any carbon dioxide. It's just that at the moment, the combination of an awful lot more people living on the planet, massive commercial projects using cement or fossil fuels, or huge agricultural, so huge amounts of animals, things like that, and kind of couple that with our oceans aren't working as they should. I'll explain that later in terms of absorbing the carbon dioxide, and obviously then we have a huge problem with deforestation, so people cutting down all our trees and they take in our carbon dioxide. So we're increasing the amount of carbon dioxide that we're putting into the atmosphere between things like a higher population, more commercial projects and things like that. And then on the flip side, we're reducing the natural things that we have on our planet that will help to absorb that carbon dioxide. So we're cutting down trees, we're making our oceans warmer, etc., etc. Okay. So yeah, that's all very important. So what I was trying to say here is that we need to have carbon dioxide. So if we have too little, and the earth becomes too cold, then it won't sustain life. And then if we have too much and the earth warms up, even a small little temperature rise, and that will affect the planet and how it functions. Okay, so that balance I talked about, which was provided by, obviously, nobody really knows at the end. We're trying to find answers in so many ways here. So like I said, deforestation is an issue, greenhouse gases are an issue, the burning of fossil fuels is an issue, but we can't go back to before the 1700s and stop all commercial activity, that obviously at the moment we have, but that's not going to be sustainable going forward. So it's trying to find another source of fuel that isn't going to damage the planet so badly. Anyway, but I suppose to reiterate, yes, too much carbon dioxide is bad, but we do need carbon dioxide. Okay, so there does need to be a balance there. But like I was saying, increased burning of fossil fuels, the balance of carbon dioxide has been dramatically affected. And now it's starting to affect our planet. Okay, so there's some numbers here. There's been a 40% increase in the level of carbon dioxide concentration in the atmosphere since the Industrial Revolution in the 1700s. And that's causing our Earth to warm up. And we talked about that the other day. So the carbon dioxide kind of sits in the atmosphere and then it reflects heat that would otherwise escape. It reflects it back in. Okay, so there's quite a few ways that we can see that our planet is struggling, but these are just kind of 3 ways we want to look at. So oceans. Okay, so the oceans are very important to the climate. They trap heat energy from the sun, which warms the water, and the warm water is then distributed about the Earth, ocean currents, and it kind of sweeps by the land, and then it warms up the land. Okay, and that's how we get heat to transfer all the way around the Earth. Okay, so most of the heat picked up by the oceans. The oceans are obviously moving bodies, so the heat moves around, and as it sweeps by the land, it heats up the land. Okay, however, there is a problem. So the oceans are becoming more acidic. Okay, so one of the really, really important things that the oceans do is that they absorb carbon dioxide. The oceans absorb approximately 40% of all the carbon dioxide that is released into the atmosphere. Okay, so the ocean, they can absorb it in 2 ways. So they either absorb it directly from the atmosphere, so directly from the air just above them, or when it rains. So carbon dioxide is dissolved in our rain. And obviously when it rains, some of that rain will go into the ocean. Carbon dioxide is acidic. So whether the ocean absorbs it from the atmosphere or it absorbs it through rain falling, it will make the water more acidic. Okay, now again, it's fine for the water to be slightly acidic. It is supposed to absorb carbon dioxide. But the problem is there's so much carbon dioxide now that you are making the ocean so acidic that animals and plants have to adapt the way they live because their atmosphere is changing. So as well as absorbing the carbon dioxide, it also absorbs most of the heat that has been generated due to this increased greenhouse gas. Now, problem here, okay? Cold water absorbs carbon dioxide much more easily than warm water. Okay, and we want it to absorb the carbon dioxide, obviously, because that kind of gets it out of our atmosphere. We want it to absorb the carbon dioxide. But the problem is, the oceans are getting warmer. So the warmer the oceans are, the less able they are to absorb the carbon dioxide. So what happens then is the heat, so the burning of the fossil fuels and the heat that's produced with these carbon dioxide, it's going to get, if the oceans can't take 90% of it, it's just going to be left in the atmosphere. And then that's going to cause us to heat up even more. Okay, so kind of a couple of things happening there. We want the oceans to take the carbon dioxide. Okay, that's what we want. There are 2 problems. The first one being that there's too much carbon dioxide, and carbon dioxide is acidic, and that's affecting the animal life within our oceans. So we need to reduce the amount of carbon dioxide. But as well as that, because our oceans are heating up because of global warming, it can't absorb as much carbon dioxide as it did before. So the problem is then that carbon dioxide has not been absorbed by the ocean, it's just been left in the atmosphere and is then causing the climate to increase or causing the planet to heat up even more. Okay, so they're kind of compounding factors. Okay, and they're seeing this already. It says here that the increase is not something that may happen in the future. This is happening now. Okay, so that's our oceans we're seeing a problem in our oceans. Another problem is surface reflectivity. So when the energy from the sun reaches the earth, some of it is absorbed and some of it is reflected. Okay, so we talked about that the other day. When it's reflected, we obviously have the problem that when it's reflected, it's not getting out. Okay, so that's a problem. But there's actually more, and like again, a compounding, another problem with the reflection. Okay, so you would have heard like black attracts the sun kind of thing. Okay, and it's true. Lighter colors, for example, snow, ice, clouds. So the more light the colour is, the more heat is reflected back. So the snow, the polar ice caps, things like that, the ice up there, it acts like a mirror. So when the sun strikes it, it just reflects it back up. Okay? And then the darker colour objects, like our oceans, our like soil, forest, things like that, anything that will be darker, they would absorb the heat. And it's meant to be like a 70-30. So 70% is absorbed and 30% is reflected. Problem is, though, as our planet heats up, the ice is melting. So we don't have mirrors as big as they used to be. So the parts of our planet that used to be pretty much covered in ice in winter, that's reducing all the time because the ice is melting into the oceans because the oceans are warmer. So now our mirrors are smaller, so you're messing with that 70-30 balance, and we're not getting as much of the sun's energy being reflected. So as well as the fact that the energy that's being reflected is being sent back by the carbon dioxide in our atmosphere, we're actually not even reflecting as much as we used to. Again, heating up the planet. Okay, and then the third one is a thing called global dimming. So this is newer, as in they're kind of only noticing this since the 1950s. So when they burn the fossil fuels, we're releasing greenhouse gas in the atmosphere. We know that, but there's also particles being released, such as soot, ash, things into the air. These little particles that are released into the air allow water vapor to gather on them, and then they make larger clouds. So the more fossil fuels we burn, the more particles there will be in the atmosphere, and the greater the amount of water within the clouds. Okay, so yeah, okay. It says it here. In simple terms, polluted clouds contain more water than unpolluted clouds. Okay, and then these clouds act like mirrors, and they reflect the sunlight back into space. So it doesn't break through these clouds. Okay, so this is kind of counter to what we were talking about a minute ago about the reflectivity. Okay, so this is a situation where we want the sun to get into the ground and the surface and the ocean, but it's not. It's bouncing back off these clouds that are being formed from the little aerosol particles that are going up into the air. And again, like, even though it's counter to what's happening up here, and you feel like, oh well, that's a good thing, it's not, because it's only happening in certain parts of the world, and then you're getting basically what happens here is that the result of global dimming is that the water in the northern hemisphere has become cooler due to the reflection of solar energy back into space. So again, this is causing our oceans to cool down, but we're avoiding that balance. It's cooling down too much. What happens then is evaporation takes place at slower rates, and we get drought, rainfall. It stops. It has caused rainfall in certain parts of the world to significantly lower, resulting in drought. Okay, so because we're not getting that heat energy through to cause the evaporation, and then the evaporation occurs, that goes up into your clouds, and then you have the water cycle occurring. So when the evaporation occurs, they go up into the clouds, you have water vapor forming in the clouds, and then it rains. And then that evaporates, it goes back into the clouds, it rains, and so on and so forth. Because the evaporation is happening so much slower, because we can't get the heat energy through to evaporate, then you don't have the rainfall. It's basically interrupting the water cycle. Okay, so they are three issues that we are currently seeing, among others, which are being caused by the the concentration of carbon dioxide in our atmosphere. Okay, now when you're taking your notes down, you don't need that kind of detail. Okay, so a brief description on how the oceans are being affected, a brief description on surface reflectivity, and a brief description on global dimming and how it's affecting. Okay, and I'll put up your homework assignment.